Okay, exam season is here, but hey, no need to panic. We're going to do a super fast power through of some key science concepts. Ready to do a little cramming? Let's dive right in.
73. For some of you, maybe that's how many days you have left until the big exam. For others, it probably feels like the number of topics you still have to get through. I know the feeling.
Yeah, I totally get it. It can feel like this mountain of information, and the pressure is real. But you know what? We're about to change all that. And that is exactly why we're here. We're going to take what looks like a typical study sheet, that jumble of notes, and we're going to turn it into clear, solid knowledge that you can actually use. And we're going to do it fast. So this is what we're working with today, a classic student study guide, right? It's packed with questions, little diagrams, key terms, the whole shebang. Let's just treat this as our own personal cram sheet and we'll master it together.
All right, let's kick things off with some everyday physics and chemistry. Trust me, these are the kinds of questions that just love to show up on exams.
Okay, first question right off the sheet. We see fuses all the time, right? In plugs, in cars, but what do they actually do?
It's actually a pretty simple but totally brilliant 4-step safety plan. Here's how it works. If the electrical current gets too high, that tiny little wire inside the fuse, the one with a really low melting point, it just heats up and melts. Poof! The circuit's broken, power's cut, and your expensive phone or computer is saved from getting totally fried. So the key takeaway? The fuse basically sacrifices itself to protect your devices. Pretty cool, huh?
Okay, next up, a chemistry classic. You've probably seen this experiment. You take a regular old iron nail, you drop it into this bright blue liquid, wait a little while, and when you pull it out, bam, it's a totally different color. So what's the deal? What's the science behind that magic trick? Well, the magic phrase you need to remember is displacement reaction. And honestly, it's exactly what it sounds like. One element is literally pushing another one right out of its spot. And this table, it lays out the whole story perfectly. So you start with your blue copper sulfate solution and a plain iron nail. Now, the key thing to get here is that some metals are just more reactive than others. And in this case, iron is more reactive than copper. So it kind of bullies the copper out of the solution. It's like, hey, I'm taking your place. So after the reaction, you're left with this light green iron sulfate solution, and that copper that got kicked out, it forms a new reddish-brown coat all over the nail. And that equation at the bottom, that's just the chemistry way of writing down this whole swap. Okay, let's switch gears from chemicals to biology. We're going to jump right inside the human brain and take a look at two really critical control centers. Oh, this is a great comparison. So on one side, you've got the medulla. The easiest way to think about it is as your body's autopilot. It handles all the stuff you don't have to think about. Blood pressure, salivating, even vomiting. Then on the other side, you've got the cerebellum. This is your master of coordination. It's all about the voluntary actions, making sure your movements are precise and that you can stand up without falling over. So a simple way to remember it, medulla is automatic, cerebellum is precision control. All right, let's pivot back to chemistry for a second, but this time we're going to get visual. We're going to look at how chemists actually draw the way atoms connect with each other to build molecules. So the study sheet asks for the dot structures of nitrogen and propyne. Don't let the name intimidate you. It's really just a simple visual way of showing exactly how atoms are sharing their electrons to stick together. Okay, let's break these down. Over on the left, we've got nitrogen. See those two N atoms connected by 3 lines? That's a triple bond. It means they're sharing 3 pairs of electrons. You can think of it like a super strong triple knot. That's why nitrogen gas is so stable. Then over on the right, you see propyne. It's got a mix of things going on. You've got your simple single bonds, but look, there's another one of those powerful triple bonds between 2 of the carbon atoms. These simple dots and lines, that's it. That's the fundamental language of chemistry. Okay, let's go from theory to practice. A huge part of science, and let's be real, a huge part of science exams, is being able to look at a diagram of an experiment and actually understand what's happening. Let's decode this lab setup from the notes. So the whole point here is to see how steam reacts with a metal. Let's just follow the flow. You've got a flame heating this water-soaked material, right? That makes steam. The steam then flows over the metal sample in this tube, which causes a reaction. And if any gas is produced, it travels down this delivery tube and gets collected over here over water. Being able to trace that path and figure out what each part does, that's a seriously key skill for your exam.
Okay, let's zoom out for a minute. We've been breaking down the content of these notes, right? The actual science. But what can the notes themselves tell us about the method of studying? Now, you're probably looking at this and thinking, I have no idea what that says. And you're right, this is written in the Kannada language. But for what we're about to talk about, the language itself doesn't actually matter. Because check this out, no matter what language it's in, the structure is totally universal. This is a classic, super powerful study technique. It's a table, and it's most likely listing things like glands, the hormones they release, and what those hormones do. See how it takes a ton of complex info and organizes it into a clean, simple format? That's perfect for memorization. This is how you conquer huge amounts of information, people. Organize it, list it out, and review it. So, we've covered physics, chemistry, biology, even a little bit of study strategy. But there is one last note on this sheet. And honestly, it might just be the most important one of all. Look at that, right there, handwritten on the page. In the middle of all the formulas and diagrams and chemical reactions is the real core message. The mental game of studying is every bit as important as the academic part. So don't get discouraged. You just got to keep going. You've absolutely got this. Seriously. We just blazed through a ton of material and you followed along. So the only question left is, what's that one concept you're going to go and review right after this? Whatever it is, go get it.